can you solve this geometry challenge? Here's the question. So given this right triangle ABC with a semicircle right over here, now let's draw the radius of this semicircle, and let's call this as R. Now given that the length of the side AB must be equal to 1, and this AC equals square root of 2, then our goal in this question is to find the numerical value of the radius, R. Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so given this figure, and also given that AB equals 1 and AC equals square root of 2 units, then our goal is to find the numerical value of this radius, R. Now, to answer this question, of course, let's utilize the given. We know that AB must be equal to 1. So we know from here to here, A to B must be equal to 1 units. And from this A to C, this is square root of 2 units. Now, let's focus on this figure. Alright, so what can we say? If we use Pythagorean theorem, we get that BC, or the length of BC, must be equal to 1. If we use Pythagorean theorem. Or, if we know the property of 45, 45, 90 right triangle, if this is square root of 2, this is 1, and obviously the other leg must be equal to 1. Because this triangle is an isosceles right triangle. Meaning, this angle A is 45 degrees, and this angle C is also 45 degrees. Alright, so we can say that this BC, or the length of BC, must be also equal to 1. Now, what we're going to do is to complete this right triangle. And yes, I know, this is a right triangle, but what we're going to do is to complete this. So, what I say is, take this figure and flip this right about here. So, what we're going to do is to get this figure, the whole figure, and flip it, so that we have a circle inside a right triangle. This is a right triangle because this angle right over here is 45 degrees, and this angle must be 45 degrees, so this is a right triangle. Now, let's call this vertex be equal to C prime. And now, from here, we can say that the length of C prime to B must be also equal to 1. And the length of C prime going to C must be equal to 1 plus 1, or simply equal to 2, because 1 plus 1 is just 2. Now, AC must be also equal to AC prime. So, AC prime must be also equal to square root of 2 units. Now, take note again that this angle right over here is 90 degrees because we have 45 plus another 45 degrees. Now, to solve for the radius of the circle inside of a right triangle, we will use this concept that it says that the radius of a circle inside of any right triangle must be equal to the sum of the legs of this right triangle minus the hypotenuse divided by 2. So let's use this. So if we use this concept in our right triangle, we can say that the length of the radius must be equal to square root of 2 plus square root of 2, the length of the side of this right triangle, minus the length of the hypotenuse, which is 2, then divide this by 2. Now, let's simplify this. So, square root of 2 plus square root of 2, this is just 2 times square root of 2. Now, 2 times square root of 2 minus 2 divided by 2, we can divide both terms by 2. So, this will give us square root of 2 minus 1. And that is the length of the radius of this circle or semicircle. Therefore, our answer to this question, given this figure and AB equals 1, AC equals square root of 2, then the length of this radius must be equal to square root of 2 minus 1 units. And as always, we are done. And of course, there's a lot of possible way to answer this kind of question. And if you have one, just comment your answer on the comment section down below. Also, if you like this video, kindly share, like, and follow our page for more content like this. And as always, we are done once again.